Hello everyone, and welcome back to my channel. This is Vishnu and Jipudi, and I'm glad that you are all here. Today, we will be solving LeetCode problem number 67, add binary. The problem reads, given two binary strings, return their stub, also a binary string. The input strings are both non-empty and contain only characters 1 or 0. So, for those of you who don't know, a binary number is just an expression of a number that is similar to base 10 numbers. For example, take the number 231. This is equal to 2 times 100 plus 3 times 10 plus 1 times 1. Likewise, in binary, the number 34, the number 23 is equal to, 1 times 2 to the 4th plus, then you look down, 1 times 2 to the 3rd. Wait, oops. Yeah, that doesn't work. So 1 times 2 squared plus 1 times 2 to the 1st plus 1 times 2 to the 0. Just like in the top example, this 100 is actually 10 squared. 10 is 10 to the 1st, and 1 is 10 to the 0. So my thoughts were, it's based, and when you add binary numbers, like for example 11 plus 1, the way you do it is like when adding normal base 10 numbers, if there's a 2 at the end, then you carry the 2. So for example, this would equal 12, right? But since it's base 2, you have to carry the 2. So then that would equal to 2, 0. But then, once again, you have to carry the 2. So that equals 100. So now that we understand the concept of these binary numbers, let me just comment that out, we can begin to solve this problem. So my first thought was to create an array list that has an element for each digit of the binary number. Okay, so let's create a new array list, integer, num binary equals new array list integer So once again, so we're going to create a new array list integer, and now we're going to want to add these two numbers, right? So int num a equals integer dot parse int string b, right? And string a. Likewise, int num b will equal integer dot parse int b. And now we have int sum equals num a plus num b. And now we have our integer of the sum. So now we put for int, okay, and then string sumster equals sum an integer dot toString sum. So let's see here. And so now that we have a string of the sum, we can add each digit of the sum to the array list. So for int I equals 0, I less than sumster dot length I plus plus. So once again, let's just create a character to the int method, because that makes converting much easier. S equals character to string C, int I equals integer dot parse int s, return I. Okay, so now that we have our char to int method completed, we can just put num binary dot add, and then we want to add char to int. Wait, so let's first create a variable. No, char digit equals char to int sum stir dot char at I, and num binary to add per digit. So now we have an array list that contains each digit of this number, and our next step would be to convert it to base 2. So now let's create another method, array list integer. Okay, so I just checked, and it turns out that list would be better for our implementation, and you will see why soon. So a list is basically just an array list, but it has a few more capabilities that arrays don't. And one of those is that it can actually append elements to the beginning of a list, and you'll see why that's handy later. So convert to binary, and then list integer num binary. Okay. And then we can just use we can do this to convert once. So and then we can just run a while loop to see while there are integers. I equals 0, I less than num binary dot size I plus plus. Okay, so here instead of add per digit, you have to put the index. Wait, yeah. So next we shall run this for loop. So if num binary dot get I equals 2, if I equals 0, then we have to add another space. So list dot add 0 comma 0 means that you add it to the beginning of the list. So we have 0 comma 1 because we want to add 1 to the list. And then else list dot get, then let's see, list dot get I plus plus, then we just return list. Oops, and also these are all num-binary. Because on the last problem, even though we technically did edit the original list, it didn't work. So now that we have this done, we can just use while okay, well now we have to have int no2 equals 0, while no2 equals 0 if Then we just use a for int I equals 0, I less than num binary dot size I plus plus. We can just default this one. If num binary dot get I equals 2, not 1. No 2 equals 2 and 0. Break. No, we can't use it. So yeah. And then while no 2 is equal to 0, convert to binary, non-binary. Okay, and then we have to return a string, right? So then now we access each element of the list. So int I equals 0, I less than binary dot size I plus plus. And now we have to add. So we first need a string builder. Class B equals new string builder, empty string, sb dot append num binary dot get I, and then return sb dot toString. So now this method should work unless we have any syntax errors, so let's run. Line 6. Alright, so we've done it. We've debugged our code. So let me show you a few notable changes in our code. So first of all, according to the list definition, you need to define a list as a type of list, so we defined it as an array list. A second major edit, the rest of the major edits are like here. So we first created a debugging method called printList, which just prints out the elements in a list. And then here, in convert to binary, we made a few changes. So first of all, we use the add method and the set method to actually change the digit beforehand, and we also implemented a check method that says whether or not the number is valid. And so as you can see here, if we input the first test case, which is 1, 1, and 1, and we run our code, you can see that it's accepted as 1, 1. And here's our list that you can see. After you add them, you can see it starts out as 1, 2, but then it becomes 2, 0 after you carry it once, and then it becomes 1, 0, 0 once you carry it again, which shows that our method does work. And our output is expected, so that's good. Now if we test the second case over here, 1010 and 1011, run code. And now we can just check a large test case to see if it will take too much time. So let's just run code to see if it works. And oh, yeah. So it turned out that the key to this runtime problem was just using array addition rather than using integer.parseInt, because the Java integer method can only take so many digits, but lists can be up to infinite length, I suppose. So here you can see with these large inputs, here's our addition. So we first create two lists, num A and num B, that represent the digits of the original integer, and then we essentially add the matching slots together in order to get something that works here. And since these strings are both non-empty, we don't need to worry about these cases. So now let's check if this works. And success! Our runtime is 78 milliseconds, faster than 5% of Java Online submissions for add binary, memory usage 39.8%, and 39.8 megabytes, less than 5.62% of Java Online submissions. So we finished this LeetCode problem, and I hope you enjoyed the video. Thank you all so much for watching. It really means a lot. Please don't forget to like, share, and subscribe, as well as click the bell icon. As always, if you have any questions, comments, concerns, opinions, or any other requests, please don't forget to comment down below. We will always be there checking those requests. Once again, thank you for watching, and this is Vishnu Manjipudi signing off. Bye.